guys, alright, we're moving away from our second unit, which was our second data unit, and we're moving into our third unit, which is our probability unit. This is going to be a quick little unit, and then after we come back from Christmas break, we're going to move into measurement and geometry. Okay, so we're going to get started just on an introduction today to probability for our first video of Unit 3. Alright, so on the left side of your Cornell notes, I want you to write the blue, write probability vocabulary, and on the right, write our two definitions. Probability is the chance that something, which we call an outcome, will happen. And then an event is an act or series of acts, so several acts in a row, that causes the outcomes, that produces the outcomes. Okay, so an event would be like I roll a 3. And the event would be like I roll a die or 2 dice. And the outcome would be like I roll a 3 and a 6. Okay, so if I'm just thinking of one die, how many 3s are there on one die? Well, there's 1 3 on each die. And so the act of rolling it would be the event. Okay, and we express probability as fractions, decimals, or percents. So let's say I'm spinning something, and there's 4 possibilities on my spinner. There's 4, I'll do it up here. Alright, so I'm spinning my spinner, and there's 4 spots where it can land. 1, 2, 3, or 4. Okay, so this is my just basic spinner. So then, what are the odds that I'm going to land on a 2? What's the probability I'm going to land on a 2? Well, how many 2s are there in my spinner? There's only 1 spot that has a 2. And how many spaces are there? There's 4 spaces. So the probability that I'm going to land on a 2 is 1 out of 4, which we of course know is equal to 0.25, or 25 hundredths. Okay, this is all appropriate ways to express probability, which is also equal to 25%. And once we get that percent, we can start saying things like there's a 25% chance that I will land on a 2 when I spin this spinner. Okay? Alright, so probability is expressed from, we can express probability in words that kind of go along with our fractions, our decimals, and our percents. The first word that you need to know down here, my pen back, is impossible. Impossible means it is never going to happen. There's a 0% chance. So this would be like if I was rolling a die, your regular die, where it's 1, 2, 3, 4, 5, 6. And what's the chance that I'm going to land on or what's the probability I'm going to land on a 7? How many 7s are on this die? 0. Okay? There's 6 sides, 0 out of 6. Okay? It's never going to happen. There's no 7 on that die. That will never happen. Okay, you can use it in life too. What's the probability that Ms. Zider's going to wake up tomorrow and she's going to be 10 inches shorter? It's impossible. Okay, I'm not going to shrink 10 inches in one night. There's no probability that it's going to that would happen. Well, then you start moving up. So this is 0. Okay, so then you start moving up into this unlikely stage down here. Okay, so there's a probability that I could wake up tomorrow and maybe my feet grew a size overnight. Something crazy happened. It's probably not going to happen, but it's possible. Maybe some weird twist of fate. Same thing with like, okay, I have a deck of cards and I want to pull the Ace of Hearts. Well, how many Ace of Hearts are there in one deck of cards? There's 1 Ace of Hearts. Okay? And how many cards are there altogether that I could pull from? There's 52 cards. Okay, so it's unlikely that when I give you a whole deck of cards, you're going to pick the Ace of Hearts out, but it's possible. Okay? And so it's about a 25% chance. Now, 1 out of 52 is much less than a 25% chance, but it's still in that unlikely range. Okay, so an even chance is if there's a 50-50 shot that it's going to happen. Okay? It's an even chance. It could happen, it could not. I have a coin, and I want to flip a heads. Well, how many heads are there on a coin? 1. There's 1 head on a coin. And how many sides are there all together in a coin? What are my total what are the total outcomes I could get? There's 2. I could get heads, tails, and that's it for my coin, for your average coin. Okay, so then you get more and more likely. Okay, so that's a 50% chance is exactly 1/2. And you get more into the likely. What are the chances that Ms. Zider's going to wake up tomorrow and she's going to get up and go to school if it's a school night? Okay? It's probably pretty likely. I might wake up sick, so it's not completely certain, but it's pretty likely. It would be like, okay, if I'm rolling a die, what are the chances that I'm going to roll 1, 2, 3, or 4? Well, what are my total possible outcomes that I could get? The favorable outcomes is what we call the ones we want to get. Well, there's 1, 2, 3, or 4. There's 4. Okay, so there's 4 favorable outcomes. And then how many total outcomes do I have? I have 6, which if we reduce this is 2/3. Okay, that's pretty likely that that's going to happen. It's not exactly 75%, but it's somewhere around that range. It's in the between that 50 and 75. We would call that likely. And then certain is something that is 100% sure, absolutely going to happen. If I roll a die, what are the odds that I'm going to roll a number 1, 2, 3, 4, 5, or 6? I'm going to roll any number 1 through 6. Well, how many numbers are there 1 through 6? 1, 2, 3, 4, 5, 6. There's 6 numbers. How many sides do I have on my die? 6. That is a 100% chance that it's going to happen. Okay, if I roll a die, I'm going to roll 1, 2, 3, 4, 5, or 6. It's 100% certain. That's absolutely certain. Okay? All right, so let's go on. Okay, so write this down. Experimental probability. I want you to write this down. Experimental probability is when data is collected through observations or experiments. Okay, so you're actually studying something to find out the probability. So that's like you're flipping a coin, that kind of stuff. Okay, each result from an experiment is called an event. Let me get back to my pen. Okay, the event is rolling a die. So if I'm going to roll a die 50 times, I have 50 events in this experimental probability. Okay, the probability of an event is equal to the number of times an event occurs divided by the total number of experiments. So this is saying like, okay, what's the probability of me rolling a die or rolling a 6 when I roll a die 10 times? Okay, and you can figure out the theoretical probability, or you can actually roll the die 10 times and see what the probability is. So I'll show you. Okay, so this is the probability of an event is the number of times an event occurs. So let's say the probability of me rolling a 6 when I roll a die. Okay, so the number of times I roll a 6, let's say I roll a die 50 times and a 6 comes up 10 of those 50 times. So let's say I roll that die and I get 6 10 times. Well, how many times did I roll the die? Over 50, so it would be 10 over 50 is my probability that I will roll a 6, which of course we know is 1 over 5. Okay, so it's not exactly the same because we know the theoretical probability is that mathematical probability. What's the probability you're going to roll a 6 when you roll a die? Well, there's 1 6 on the die and there's 6 sides, so 1 over 6. Okay, but the experimental probability doesn't always have to be the same as the theoretical probability, as what should happen. Sometimes what always happens, or sometimes what actually happens, isn't what should happen. Okay, but this is experimental probability. Okay, so let's look. We're going to see the probability of this kid shooting a basketball. We're going to find the experimental probability of this kid shooting his basketball, okay? So remember, this is experimental probability. Remember, we want to look at the number of times an event occurs. So we're going to see how many times does he make the basket over how many times does he try to make the basket. Okay, so the event is scoring a basket. Number of baskets scored divided by number of shots taken is our probability. Here we go. All right, his first ball, he shoots and misses. He doesn't make the basket. So he has scored 0 baskets, but he has taken 1 shot. All right, let's try it again. His second one, oh, he makes that one. All right, so now his experimental probability is 1 over 2. He's made 1 basket, but he's taken 2 shots. And one more time. Oof, definitely didn't make that one. All right, so he's made 1 basket, but he shot the ball 3 times. So this little boy's experimental probability of making a basket is 1 over 3, or 1/3, or 33%. Okay, so this is the theoretical probability that I've been talking about before. So experimental is when you actually do that experiment, okay? You actually perform those events. All right, so write this down. Theoretical probability is when all possible events or outcomes are equally likely to occur. The theoretical probability can be found without collecting data from any experiment. That's like you're rolling a die, okay? Or if you prefer, a penny has 2 sides, okay? So we're flipping a coin, okay? When you flip a coin, there are 2 possible outcomes. You can get heads or tails, okay? So the number of favorable outcomes, this word favorable outcomes means what you want to happen. So if I want to flip a coin and get a heads, getting a heads would be my favorable outcome, okay, over the total number of possible outcomes. All right, so here I have heads is my favorable outcome, and heads or tails are all my total outcomes. Okay, so how many heads are there on a penny? There's one head on a penny. That's a 1. And how many different outcomes could I get? 2 different outcomes. So 1 over 2 is the probability that I will get a heads when I flip a coin, or 1/2 or 50%. It's an even chance. How about tails? Well, how many tails are there on a penny? There's 1 tail on a penny. And how many possible outcomes could I get when I flip a coin? 2 possible outcomes, head or tails. So there's an even chance I'm going to flip heads or tails. All right, you guys have done a great job. You can watch the next video. It should be up, or you can go ahead and come to class and we'll practice with basic probability. All right, have a great night. Bye.